Let's take a quick look at how orbiting objects like planets, minor planets, asteroids, and comets are located in space. Orbital elements are one way to precisely describe the object's orbit and location of the object on that orbit at a particular point in time. Solar system orbital positions use the Sun, the ecliptic, and the vernal equinox as reference points. This sets the plane of the ecliptic as well as the northern and southern ecliptic poles. Semi-major axis is a measure of the size of the orbit. If the orbit is circular, then this is the radius of the orbit. Eccentricity describes the elongation of the ellipse. Eccentricity ranges from 0 for a circular orbit and approaches 1 as the shape of the ellipse approaches the transition to a parabola. For solar system orbits, the ellipse has the Sun at one focus. The point of the orbit of closest approach to the Sun is perihelion. The mean anomaly is a way of indicating how far along the elliptical orbit the object currently is. Alternative specifications include using the true anomaly at a specified epoch, or the time of perihelion passage in conjunction with the orbital period. The next three steps will take the orbit out of the plane of the ecliptic. Note that there will need to be an orientation of the orbit followed by a tilt rotation to take the orbit out of the plane of the ecliptic, followed by a final alignment of the orbit. The ascending node will be that point along the orbit where the orbital path crosses the plane of the ecliptic towards the north ecliptic pole. The argument of the perihelion is the angle between the orbit perihelion and the ascending node. Inclination is the tilt of the plane of the orbit relative to the plane of the ecliptic. Finally, the longitude of the ascending node is the angle between the ascending node and the direction of the vernal equinox. Rotating the orbit by this final angle around the ecliptic pole is the final orientation element that allows the orbit and the object's current location along that orbit to be completely specified.